Hello everyone, my name is Pavani. In this video, I'm going to show you how to solve an optimization problem using Excel. Let's first see what the business problem is all about. PC Express is a computer retail store that sells two kinds of microcomputers, desktops and laptops. The company earns $600 on each desktop computer it sells and $900 on each laptop. The microcomputers PC Express sell are manufactured by another company. This manufacturer has a special order to fill for another customer and cannot ship more than 80 desktop computers and 75 laptops to PC Express next month. The employees at PC Express must spend about 2 hours installing software and checking each desktop computer they sell. They spend roughly 3 hours to complete this process for laptop computers. They expect to have about 300 hours available for this purpose during the next month. The store's management is fairly certain that they can sell all the computers they order, but are unsure how many desktops and laptops they should order to maximize the profit. Formulate an LP model for this problem, sketch the feasible region for this model, and find the optimal solution to the problem by enumerating the corner points. To solve this problem, let's first try to understand what the given information is. The company earns $600 on each desktop computer and $900 on each laptop. The manufacturer cannot ship more than 80 desktop computers and 75 laptops to PC Express next month due to another order. Each desktop needs 2 hours for installing the software and checking it. Each laptop needs 3 hours for the same. In the next month, PC Express has got only 300 working hours available. Now we want to find out the optimum number of units of desktops and laptops which have to be ordered to get maximum profits under given constraints. If we assume x1 to be the number of units of desktops and x2 to be the number of units of laptops, we can write the constraints as shown below. x1, that is the number of units of desktops, less than or equal to 80. That means the manufacturer cannot ship more than 80 desktops. x2, or the number of units of laptops, less than or equal to 75. That means the manufacturer cannot ship more than 75 laptops to the company. And the third constraint is the total number of working hours, that is x1 into 2 plus x2 into 3 cannot be more than 300 hours. It's also given in the question that each desktop is sold at $600 and each laptop is sold at $900. So the profit equation turns out to be x1 into 600 plus x2 into 900. If you try to visualize all the three constraints using a graphical form, the solution should look somewhat similar to this. The first constraint, that is x1 less than or equal to 80, can be represented by a vertical line, that is this one. And the feasible region for this particular constraint is the region which is towards the left of this line. The second constraint is x2 less than or equal to 75, which is represented by this horizontal line. The feasible region for this particular constraint is the region which is below this horizontal line. And for this particular constraint, that is the total number of working hours, that is 2x1 plus 3x2 cannot be more than 300. It can be represented by this particular slanting line. If we consider all the three constraints combined, the feasible region will be the shaded part here. Our optimum solution should also lie in this shaded region. Let's try to figure out what that optimum solution is using Excel. Here we have the selling price of desktop $600, laptop to be $900. The number of units that the manufacturer can ship cannot be more than 80 for desktops and cannot be more than 75 for laptops. Time spent on each desktop is 2 hours and time spent on each laptop is 3 hours. And here we have the decision variables, that is the number of units of desktop represented by x1 and the number of units of laptop which is represented by x2. And here we have the constraints. The number of units of desktop cannot go beyond 80. The number of units of laptop cannot go beyond 75. And this particular cell value, which represents the total number of working hours, that is 2x1 plus 3x2, cannot be more than 300. And here we have the profit equation to be the selling price of each desktop multiplied by the total number of units of desktop plus the selling price of each laptop multiplied by the total number of units of laptops. Depending upon the values given here, the values for the constraints and the value of profit will be changing. For example, set the sell value to 25 and set this particular sell value to say 40. We'll see that as these particular values changes, the values in cells D16, D17, D18 and G10 changes automatically. We can also use solver, which is available under data tab, that is here, to get the optimum number of units for both desktop and laptops. Here, to use solver, first we have to set our objective. Our objective here is to maximize the profit. The profit in this particular Excel sheet is given by G10 value. So select that cell and set it to maximum. Next, we have to mention the decision variables, that is the total number of units of desktops and laptops, that is these two particular cells. Next, we have to mention the constraints. So to add the constraints, click on Add tab and then give the first constraint, that is this particular D16 value cannot be more than 80. That is the number of desktops cannot be more than 80. Click on Add. Next particular cell value, that is the number of units of laptops cannot be more than 75. Click on Add. The last constraint will be the total number of working hours, which cannot be more than 300. Click on Add, click on Close and then click on Solve. Here our solver will give the optimum number of units for desktop and laptops. We can keep the solution or else we can ignore it. So the result which we have got by using Excel solver is 38 number of units of desktop computers and 75 units of laptop computers, and this gives the maximum profit, that is 90,000 rupees under all the three given constraints. So here the optimum solution for desktops is 38 and for laptops it is 75. A point to be noted here is that this particular solver tab is not available for everybody, but you can always add in by using options, add-ins, look for solver add-in and then try to add into your Excel. Thank you for watching.